Everyone, very welcome to this web conference at the Euronaval. My name is Martin Lundmark. I am presently at the Swedish Defense University in Stockholm, and I have been given the honor and opportunity to be the moderator of this web conference. And I work here within an institution for defense systems where I do research on autonomy on the underwater area and different sorts of defense acquisition. And without much further ado, we have 3 presenters who will talk about their specific subjects. And I would like to welcome Mr. Daniel Scourzic from ICA Robotics, who will talk about naval mine warfare. Please, Monsieur Scourzic.
Yes, hello, good morning or good afternoon, everybody. So my presentation, as Martin said, will deal with the future of naval mine warfare. And I will first start with one slide reminding about why this threat of underwater mines and naval mines should be feared. We need to keep in mind that 80% of the world trade is made by sea. You can see on the picture there the main routes, and some of them are in red because they are, I would say, heavily used, and in some of them being going through straits and choke points and these kind of things. Mine can be a cheap weapon. Some of them can be very sophisticated, but most of them can be also cheap. They can be used by terrorist organizations. And they can have a low price, but with a wide impact, disrupting the economy and making a large damage, as you will see in one of the next slides. They can be used also by navies during major conflicts for offensive mining or defensive mining, and to supply and to block supply routes. Offensive mining will be made, for example, to prevent ships leaving a harbor. And defensive mining could be also used, for example, for preventing ships entering a harbor or an area. In stock worldwide, there are hundreds of thousands of mines and maybe millions of mines. And just as a reminder, it is estimated that there are around 400,000 mines into the English channels, the North and Baltic Seas, that remain from World War II in particular. Mines are evolving, and as well as mine laying techniques. Everybody has heard about the old contact mines and influence mines. Influence mines are becoming more and more sophisticated because the sensors and the data processing and signal processing inside mines, inside the fuse, is becoming more and more sophisticated. There are a few mines, for example, that are not currently, I would say, treated at this stage, are, for example, like things like buried mines. There are new threats also appearing. Underwater IEDs. Everybody has heard about improvised explosive devices, and now you have also underwater improvised explosive devices that can be as simple as gas canisters that can be operated from the shore by terrorists or enemies. Mobile mines can be launched, for example, by submarines or surface ships, and then can transit for tens of miles underwater before reaching their, I would say, laying positions. And a new kind of mines that exist are mobile mines. They can be laid in one position and then can move to another position. So if you detect them at a given date or a given moment, when you want to identify them and to prosecute them, they may have moved, so you can't find them where you found them, when doing the survey. And the mine laying techniques also are evolving. Historically, they have been launched by surface ships, by submarines, by aircraft. And now with the large AUVs, autonomous underwater vehicles, called the, I would say, XL AUVs, they can also be laid now using AUVs. So very, I would say, quite small underwater vehicles compared to submarines that would be hard to detect. So all these new threats needs to be taken into account in the future techniques for mine countermeasure. When I said about small devices and cheap devices that can create important damages, mines that can cost, I would say, between a few $1,000s and up to, I would say, a few tens of thousands of dollars, can create very large damages and important damages on ships that are, I would say, even on warships that have been designed to withstand these kind of things. You know, the two pictures there show the damages created by contact mines and by a small, I would say, bottom mine containing only 100 kilo of explosives, and that's generated over 100 or between 100 and 200 millions of dollars of repair on the ships, and that have been, I would say, that it took between 18 and 2 years to repair. The mine countermeasure up to, I would say, now, minesweepers were used, and mine hunters that are still used by many navies worldwide. What are they? They are specialized vessels that need to enter the minefield. So I will present that in the next slide. But the ships, they have to enter the minefield to find the mine and to prosecute them. So this is dangerous for the ship and for its crew, of course. Tomorrow, robotic systems will be used. It will be systems made of autonomous underwater vehicles, made of autonomous surface vehicles, and unmanned aerial vehicles will also be used for some of the tasks, for example, for detecting drifting mines or mines that are close to the surface, but I will come on to that later. All these systems can be deployed from outside the minefield by non-specialized ships, because they can be, they do not need to enter the minefield. So the mine is not a threat for them compared to the mine hunters or minesweepers that need to enter the minefield. But these systems also can be deployed directly from the shore. So these new type of systems will be safe for the crew and for the ship. The mine hunter, as I said earlier, need to be into the minefield. And for detecting the mines, they use hull-mounted sonar or variable depth sonar for what we call detection and classification. So the sensors are attached to the vessel. And for protecting the vessel needs to have a very low magnetic signature and a very low radiating noise in order to avoid triggering the mine. But in case the mine is triggered, the vessel needs also to withstand an explosion. Okay, this is the reason why mine hunters are considered to be the most expensive vessels owned by navies compared to their size and to their displacement. For identification and neutralization, robots are deployed from the mine hunters. And this is very interesting to see that robots have been used for underwater mine warfare since the mid-70s, even before they were used into the oil and gas industry. The robot is deployed from the mine hunter, comes to the mine for identification, and then, if required, they will drop a charge next to the mine. The vehicle is recovered on board the vessel, and then the vessel can proceed to the next mine. The use of robotic system, as I said earlier, will be the future, and the future has already started now, because some robots are started to be used for detection of mines, in particular AUV. So we proceed more or less the same way. So mines will need to be detected, then classified and identified, and then neutralized. So for that, a set of robots will be used. As I said earlier, unmanned aerial vehicle can be used to detect mine very close to the surface or drifting mine. UAV will also be used for communication relay between the unmanned surface vehicles or the autonomous underwater vehicle when they are on the surface, and they will communicate to the mothership or directly to the shore. So for detecting mines, USV can be used towing side scan sonar that will survey the area. That's one way of detecting the mines. The interest of using USVs is that you can have in real time, the images that are sent to the mothership or to the shore. The limitation of towing sonars and sensors by USV is the water depth. So you can reach 100, 200, possibly 300 meters of water depth, but for deeper waters, it's quite difficult to use towed sensors without having a very big USV to tow it. Autonomous underwater vehicle will use side scan sonar, synthetic aperture sonar, to detect the mines. So because of the lack of, I would say, communication or difficulty of communication underwater, the vehicle will have to record the data and to pre-process the data inside the vehicle with embedded data processing. So to communicate the information to the ship or to the shore, the vehicle will have to come back to the surface to communicate and transfer the data that has been pre-processed in order to save time. Otherwise, you have to wait for the vehicle to be recovered to recover the data. So from time to time during the mission that is planned, the AUV will come to the surface and transfer its data. When this information is processed by the crew of the ship or by the crew onshore, then you will have to identify the mines. And for that, in the first, I would say, instance or in the coming years, USVs will be used, so unmanned surface vehicle will be used to launch small mine identification and disposal vehicles. So the small vehicle that is called there the EMDS will be transiting automatically from the USV to the object to be identified or prosecuted, and only during the final stage of the mission the operator can come into the loop for making the final decision for prosecuting the mine, for example. As I said earlier, minesweepers were used in the past, but the minesweeping, for doing minesweeping, you try to trigger the fuse of the mine. And for that, the sweep is towed behind the vessel. So it means that first the vessel needs to go over the mine. When using robotic systems, the USV is remotely operated, so the crew is not endangered. And the USV will tow a sweep to try to replicate the inference generated or the signatures generated by the ship, both acoustic and magnetic and electric. What are the advantages of the robotic systems? As I said earlier, the crew and the ship remain outside the mines field, so it is safe. Compared to a conventional mine hunter that does the task, I would say, in sequence, detection, classification, then neutralization, identification and neutralization, first for each mine. Robots can be used simultaneously in a parallel zone. You will, I would say, divide your mine hunting zone in various areas, and while one system is detecting the mines, the other system can identify them and prosecute them. And since the robots are independent from the ship, it is flexible because you can have as many as systems, provided of course you can have them on board the vessel, deployed at the given time. And you can combine also the deployment of robots from the ship to robots that can be deployed from the shore directly. What is illustrated there into the picture is the system that ECA will be delivering to the Belgian and Dutch Navy as part of the contract that was awarded to ECA and Naval Group 1.5 years ago. So it is a combination of USVs that will deploy side-scan sonar to side-scan sonar that will launch and recover autonomous underwater vehicles, and then will launch also or deploy mine identification and neutralization vehicles. To conclude this short presentation, we think that the future of mine warfare is the extensive use of system of robots, keeping the crew and the ship safe outside the danger area, with USVs and AUV that can be directly deployed from the shore. System will become increasingly autonomous, of course, under human supervision, and we can imagine that in the future, in particular in wartime, decision can be taken directly by the robots to prosecute mines, for example. The system will need to be more and more cyber secure, with extensive use of artificial intelligence, swarming, and other kind of techniques that will need to be developed in the coming years. And I think that concludes my presentation.
Thank you very much. I would like to remind the people who are participating in this conference that you can pose questions in the chat, and they will be moderated not by me, but by my colleague Hélène Masson. And I should also say that I forgot that in the beginning. I'm so sorry that this web conference theme is technological innovations and capacity shortfalls. Well, if there are no other questions right now, I have one question. When you're using different sorts of autonomous vehicles, what kind of ethical challenges arise when dealing with these mines?
Sorry, can you repeat?
When you're using autonomous vehicles of different kinds in mine warfare, what ethical challenges arise in order to do this the best way?
First of all, during all the phases of detection and classification, you're only trying to find the object that can be potentially dangerous. The only, I would say, time where you may be having ethical decision to be made is when you want to prosecute the mine. So mines may not need to be prosecuted in place where they are. You can also decide to move the mine and maybe to dispose of the mine in a safer place, maybe with less damages to the environment. But it depends on the circumstances when the system is used. Is that peacetime? Is that crisis time? Is that wartime? And I think the decision in that case can be quite different.
Okay, thank you. So I understand now that we will have questions after the three presenters. So now we will move on to Jean-Jacques de Larivière from MBDA, who will talk about new advanced technologies for maritime superiority. Please, Monsieur de Larivière.
Thank you very much. Good morning, everybody. So yeah, I've been asked to address a wide subject, and it's this wide subject is not concerning only MBDA or any kind of missile company as MBDA is. The battle for technology is as old as war exists on the world. So it is. I will focus my today presentation on some systems that obviously are done and developed by MBDA. And one of the key elements here is MBDA is addressing today the needs of the three armed forces in different countries, and it's a key element. As today, a single conflict is not conducted on a single battlefield, but we have to be aware that the war at sea today is connected to all battlefields. So the maritime superiority is today well challenged, and one of the main reasons is we are switching from asymmetric crises to some high-intensity scenarios that are asked by many headquarters and the Minister of Defense. That is changing the perception of the need for those armed forces as the threat is evolving to a high end. So when you want to understand how we can keep maritime superiority, the first thing you have to do is to look at the game changer. What are the game changers that are today challenging the navies that are sailing at sea? The most obvious assessment I will do is that the coastline today, the coastline is not anymore the limit between the maritime superiority and any kind of land superiority. Everything is mixed. If I take the example today of the range of different weapons that are used by land forces or maritime forces, the range are more than 1,000 kilometers and way more. So are you safe? And are you able to maintain your maritime superiority if you are in the middle of the North Sea or in the middle of the Mediterranean Sea? That is today challenged by those new threats. So on this slide, I will see that the game changers are on two sides. On the left side, you have the defensive capabilities that are needed from our modern Navy to address those new threats. And on the right side, you need some new offensive capabilities on every battlefield to be able to address those threats, but also to be able to challenge them and to put the stress on them as you are at sea while you're doing an operation. So if I do a focus now on the defensive capabilities, so for sure today you have seen many times, it's well known that some new threats are emerging. The ballistic missiles, some hypersonic missiles. We had a great example last week with the Russian Navy making a demonstration of a second missile launch, which is an hypersonic missile. There is also the saturating attack, which is also new. With the saturating attack, we have to bear in mind that this is a return of the combat mass. Saturating attack is not something new. It's just, it was always existing. But now it is a return of the combat mass. And how can we address a combat mass? Can we address it with technology? Or do we need to address also with combat mass? So we may need some new weapons to address that. Most of the time people are seeking of direct energy weapons. But it's also, when you want to address combat mass, you need mass. So you need a certain amount of effector inside your task force to address those saturating attacks. And I will add also on those, among those new threats, some threats that are most of the time sort as threats that concern some army or air force armored forces, which is IADS, so Integrated Air Defense System, or some airstrike. Those concern as well the Navy, as those air defense systems are wide now, and the range capability of their system is able to go above the sea. And when you want to use the 3D and some aircraft or UAV in your Navy, you need to address this threat as well. So on the offensive capability, the main point here is the ability is to do some offensive capabilities on every battlefield. For sure, at sea, it is obvious when you want to perform a maritime superiority, but you need to do that in the air, in the space, over land, and obviously in the cyber battlefield. If I focus more now on the power projection and the ability to project power, it is most of the time what our modern Navy in Europe are looking for. And we can see that many navies now are using some cruise missile capability to strike, to do some deep strike in enemy territory. They have also some aircraft carrier able to launch some aircraft to project the power. So this is a huge threat for ground forces. And those ground forces they are challenging the maritime superiority. We need to address as well those forces. And this is part of the maritime superiority. To project power is part of the maritime superiority. So how I will highlight, I think that's four key elements that are needed now to be able to challenge the game changers. The first one, and there are two, they are very linked, is your ability to build your situation awareness and connectivity. That also has always existed, but now when you want to address the connectivity and your situation awareness, you have to think that to a higher level situation awareness. It has to be at sea and also on the ground. So it's a wide area, and you have also think that your situation awareness need to be able also to do some interoperability between nations, as most of the Navy now are deployed not as a single country, but in a coalition. And there is two other things that are key elements. It's managing the military effect and the increased range of the weapons you need. So for the range, if you want to project power with a missile from a ship, it's a question of size. The range depends on the size of your missile. And it will be always an advantage for the ground forces. There is no limitation of size when you're on the ground. But that's why when you want to be able to project power, you need at the same time to be able to operate under the threat of your enemy. And for the managing the military effect, it means that you don't have to focus anymore only on lethal effect when you have some weapons. You need some scalable effect, you need some non-lethal effect. So all that, it's a lot of new technology that are developed today, and we are thinking about those new technologies in MBDA. So now I will focus on one key element that I think is part of the answer and the need of our modern Navy today to address this maritime superiority. To face a threat, you need technology and mass. Okay, so I think collaborative answer is needed. On the left of this slide, you can see that mission planning and building your situation awareness, this is an everyday job of every Navy. They need time for that, and it can be a long process. And it's obviously a collaborative or collective understanding of the situation by every ships that are deployed, but not only, but any assets that are needed inside the task force. So the challenge now is to operate under time constraint, and to do that while you are engaged and when you want to engage. So it's not anymore the collaborative combat only, but that's the collaborative engagement. How to make sure that in time constraint, you are able to do a quick action with a lot of new weapons, a lot of new sensors, and to gather them to be able to have an effective collective answer to the threat. For that, you need, as shown, decision aids, firing control to do your engagement, and it's a on and on process. So you go to a collaborative inside the task force, you go to your terminal engagement validation, and then you need to assess what you have done with the battle damage assessments or the battle damage information, the BDA and BDI. All that is a circle, and you do that all the time while you're doing your operation. And some key element here as are written. I may go back. I will not go inside the detail because I don't have the time to do that. But just for you to see that those key elements inside the collaborative engagement are for sure the collectivity and data fusions that are part of the collective or collaborative situational awareness building. But inside that, you need some artificial intelligence. You need your effector to be collaborative as well. So you need a teaming between man and effectors. You need to use some meta-sensing between your effectors. And also the payloads command and control. Who is going to, as your payload will be smarter, who is going to control those payload? Is it someone from the ship launching? Is it someone else? That's an issue you needed to be addressed when you want to master this technology. And also the trajectory control and the retargeting, as the enemy will give you some surprise all the time, and so you need to adapt yourself. And finally, I wanted to show you that where the Navy stands today, some European countries are setting some new major program to address the new threats. Those new threats do not concern only the navies; they concern the Army and the Air Force as well. So, for example, those new major programs in Europe are the Tempest, which is an air combat system for UK and Italy, the FCAS program, the Future Combat Air System, which is the Franco-German-Spain program. You have also the other major Franco-German program as the main ground combat system or the maritime air warfare system. So the last one, you can see, think maybe it's concerning the Navy, but it's dedicated to submarine warfare. So all those major programs are a good example of collaborative system and multi-domain system as well. So those programs will have a great influence in our Navy. And if I take the example of the Future Combat Air System that are developed by France, Germany, and Spain, the aircraft inside this program, the new generation fighter, will be a carrier-borne aircraft. It will be sailing on the French carrier. So this is typically where the maritime superiority meets the air superiority, and it's the Navy need to address that. And inside those major programs, what you find? You would find a combat cloud, and you would find some new effectors that are launched from a ship or from an aircraft. So the navies have to be ready to take into account those kind of new capabilities. On this slide, you can see that, for example, MBDA is developing some remote carriers with a swarming technology and with a difficult subject, which is a man-weapon teaming. Where do you set the automatization of those systems to be sure that you will always do the effect you want? And all that is part of the digitalization of the battlefield for sure. So to conclude, I will, if you have something, I think the key elements here today are that the collaborative engagement is a key of the maritime supremacy today. And inside collaborative engagement, it's not between ships only. It's between all assets that are part of the maritime superiority. And ground forces will challenge them as well. Don't forget them. To do that, inside this collaborative engagement, you need smarter effectors to be able to get inside those contested areas that are melted between sea and ground. And smarter effector mean to address the man-weapon teaming, which is a complex subject. And all that, you will be able to connect all the battlefield to address this maritime superiority. Well, thank you very much.
Okay, thank you very much. And now we have 1% left, and I can see that there are a lot of questions coming in. Please keep sending questions over the chat, and we will try to find the most interesting questions among all these questions. Now we have our third presenter, which is Olivier Kermagoret from Thales, who will talk about combat cloud and naval domain. Please, Monsieur Kermagoret.
Yeah, good morning. Today we all notice that threat is changing. Our ability to ensure information superiority is today being really challenged by a new actor. For example, cyber threat from a terrorist group or high-intensity combat capabilities coming from state navy forces, including, as you know, electronic warfare or jamming. You have also new type of threat, such as hyperspeed weaponry or electronic warfare, have left the science fiction realm to become today an operational reality. This presentation, we speak of how new cloud and information systems will gather and bring some new answers in this domain, taking account that those answers are not unique. It depends on the level of deployment you will adopt, if you are on a strategic deployment, operational deployment, or tactical deployment. Today in France, response is enhance agility through naval collaborative warfare. I go to slide 2. As I said before, the operational environment is moving fast. France's ability to inform for information superiority at sea is being challenged by air and maritime superiority. Is not granted anymore. Secure and safe use of satellite is at stake. The electronic warfare domain is today really crowded, especially with, for example, with some Russian or other capability. And in the digital domain, stand many emerging opportunities together with new threats, especially related to the cyber field. More and more emerging high-intensity level capable foes. Yesterday, we have some asymmetrical threat. Today, we notice that there is a real high-intensity capability in the sea. More and more various threats at low intensity level, like as I said before, cyber threat, and border between peace and war threshold are always blurrier. Facing those new menacing paradigms, naval collaborating warfare principles are based on 3 various timescales. The first one is the enduring timescale at strategic level. The operational tempo is mainly asynchronous at this level. You see it on the top of the slide. Indeed, at the enduring timescale tempo, it is paramount to make sure that information is both highly consolidated and available for analysis and decision support through private cloud deployed in metropole data centers and securely received by all interested operational participants. Technologically, this enduring timescale is based on a combination of civilian cloud technology and a strategic communication capability between home, metropolitan home, and the aeronaval battle force ashore. This strategic link being both a bottleneck for classical cloud technology and the one thing that differentiates the naval core cloud from, I would say, civilian cloud. Latency is not necessarily a problem at this enduring timescale tempo. Therefore, security and safety of data, capability of analysis and sharing information is key at this level. Also at this level, the service provided by the cloud are mainly C4 application, full big data capabilities, machine learning, but also enterprise service like collaborative tools, you all know, like messaging, chat, and so on. The second timescale is a real-time timescale. Real-time timescale is really key to the operational level of operation within the aeronaval force. The combat management system role is to gather at this level real-time information in due time so that the operational watchkeeper can timely and efficiently conduct the operation. Technologically, we could speak about a naval embedded cloud, what we call a cloud edge, whether this embedded cloud stands for embedded within the whole battle force or only inside the main frigate, depending on the level of maturity of the force. Our expectation is also that following the NATO Federated Mission Network timeline, we would be able to reach the whole battle force level of maturity by 2030. At this cloud level, the services are mainly command, data fusion, and intel application with full artificial intelligence capability. On the bottom of the figure, you can also see the immediate timescale. Faster than real-time computing, orchestrated sensor-to-sensor or sensor-to-effectors, information sharing among all sensors of all the platforms constituting the battle force, aerial, naval, underwater, etc. At a tactical level, the immediate timescale is to become the true game changer, multi-sensor, multi-level, supported by medium Earth orbited or low Earth orbited satellites. Or, if you have it, line of sight communication means for no latency. The sensor-to-sensor or sensor-to-effector immediate timescale purpose is to provide versatility and agility to the battle force at the right tempo to face the forthcoming threat. We call it the cloud far edge. Actual orchestration technologies and communication bring next food for thought in the doctrinal and technological cycles in order to fulfill the operational requirement within this new aeronaval battlefield environment. In this figure, you can see a mix of those timescales, enduring, real-time, and immediate time, with their characteristic in terms of level, strategic, operational, and tactical. Also, in terms of technology, as you can see, the enduring timescale is mostly based on civilian technology with specific security feature and specific network capability. You can also see some real-time scale are based on civilian with specific security and form factor specification. And you have also an immediate timescale, which are based on defense specifics technology. We have some standard today for enduring timescale and real timescale, mostly based on NATO FMN standards, FMN for Federated Mission Network. But today, in our opinion, there is no real standard for sensor-to-sensor or sensor-to-effector standard which will allow them to communicate effectively. In terms of location, the solution for enduring timescale are mostly based on data centers based in the country of the naval force. The real-time scale is based on some data center edge embedded, for example, on some aircraft carrier, and the far edge capabilities is deployed on every warship. To conclude, those three timescales are permanently active when the battle force is at sea. It is the operational phase that drives the load balancing between all three various efforts and purpose, but in the midst of it all stands the data and the capability to use them for combat or decision. Actually, the whole story is about sharing the right data at the right moment in operation among all the appropriate actors. Hence, creating a new paradigm of life cycle application through short time cycle development corresponding to changing needs. With an ever-accelerating OODA loop, all three timescales have their share in the response as key to the naval collaborative warfare.
Anyhow, we have some questions here from the people who have been listening to this. And for the first presentation, one question is, what do you consider to be the main cyber threats for autonomous robots?
There may be several threats, but maybe the main one can be that somebody takes control of the robot itself, because he can set a recovery point or a transit area that you don't want, and that would enable somebody to get the robot the information it contains. But there are some countermeasures for that, such as if the system is not, or the robot is not in the assigned area, you can decide to erase the data. You can decide for the robot, to sink. I would say to go in the water. So there are countermeasures for that. But this is, I think, the main threat, because people can get the technology and the data recorded by the robot.
Okay, thank you. What are the with the when you have these autonomous vessels and you don't have crew who are close to the contested area or the battlefield, then you need new types of operators. Will they be on the ships, or may they be on the ground or in an airplane?
I would say everything can be imagined there. Currently, they can be both on the ship or on the shore. It depends on where your operation center is located. It will depend also on the communication bandwidth you have and the range of communication that you have to obtain. I would say, but at this stage, they can be on board the vessel. They can be on the shore. They can be on a dedicated vessel or a specialized vessel. They can be, I would say, almost anywhere, provided you have the means of communication to transfer the data. One way to transfer the data also is to pre-process the data on board the robots themselves, to transfer only the required information and not the raw data.
Okay, thank you. And now a question to the second presenter, could also be the first presenter, I believe. There's a lot of development in the civil, non-military area. What are the main contributions of the civil non-military development in technologies that will help to forward the capabilities that you're talking about?
Maybe I can answer first. The sensors are becoming more and more compact, not only for the sensors, data processing systems are becoming more and more compact and are using less and less power. So all that is really in service, or this type of sensors are used into the civil world and can be leveraged to be used for the military business or so. So I think the trend is the same. The computers were quite big a few decades ago. They are very compact today compared to what they were. So, and the needs for both the civilian world and the military world is the same.
And I believe that was Monsieur de Larivière. What about Daniel Scourzic? Do you have other things to say?
No, I already answered this to Jean-Jacques.
Yeah, if I may add, basically the same conclusion like Daniel. It's militarization is a key element and it will be obvious help the military defense industry to especially MBDA, as we have to put everything in missile, and its militarization is a key element. But regarding some new technology, laser is definitely used massively in the civilian war. The direct energy weapon is looked closely today. Laser. It's the same for radio frequency direct energy weapons. So those kind of system of developments are in between civilians development and military industry development.
Okay, thank you.
Sorry, if I just may add one thing is the communication. 4G, 5G, all these kinds of things can be of high interest even for autonomous systems to communicate between them, provided, of course, they are cyber secure.
Well, to my knowledge, a lot of these civilian technologies that are emerging, they don't have the same demand in order to be non-detectable, to have a stealth performance. Do you meet a lot of challenges in putting these civilian technologies and sensors into the systems?
Well, it has to be definitely addressed by with the regard of the needs of the operational armored forces. You can't take all the civilians' technology and put them directly. There is an adaptation, but it's the time frame and the tempo and it's of the innovation loop is have to be also part of the new technology we have to develop in defense industry. We cannot wait years. The technology is moving forward very quickly, and we have to look at that carefully to take what is needed for us.
Thank you. One thing that I was thinking about here is that when you're using 5G technologies or cloud technologies, these can be very fast, extremely fast when you're using air as a communication. But when you're underwater, then it's more difficult to have a communication that is real time. What kind of challenges does this put to the system, since you will be more detectable if you're using wired communication?
For underwater vehicles, you are totally correct. Underwater communication is, I would say, you don't have bandwidth. You have range limitations that you don't have, into the air with radio communication. So one way for, I would say, trying to solve the problem is to have embedded processing inside the vehicles, and only to transfer a limited amount of information. You were referring into my last slide about swarming. So to do real swarming, you need to communicate between the vehicles, so that one vehicle can transfer its information to another vehicle, maybe for replanning a task and or for I would say acting in another area. But for doing that, you will need to communicate, and to communicate underwater is a real challenge. And I think that there is a field of research to be conducted in that area to assess maybe other technologies than acoustic communication, that is the one that is used currently mainly today. So I think that in terms of research, there is some activity to be done there to find other ways of communicating. One way why are autonomous robots really autonomous now is because of the lack of communication long range and the lack of bandwidth.
Thank you.
Yeah,
I would like to address another question, more general, to the three of you. You have listed very many different technologies that are important in reaching these new capabilities. Is there one or maybe just two or so technologies that are most important for forwarding these capabilities that you have described?
Yeah, I may start with the cloud. The cloud today, the main challenge, there is two main challenging for the cloud embedded on some boat and in Metropole. The first one is to provide sufficient network and also resilient network, which are, for example, jamming proof, because if you use 5G, you may have some jamming problem quickly. And the second technology, which is a challenge and a real game changer in IT and information system, are virtualized orchestrators. Those orchestrators allow sensors, effectors, and IT systems to communicate all along the chain of command and effection and sensors.
Thank you.
Yeah, if I follow on I think I totally my answer will be very close to the one of Olivier. We may think that connectivity is a limitation. I think I will say it's the opposite. We have to be ready that the connectivity will not be anymore a limitation for the armed forces, and that will be the main game changer. Everything will be connected, so the challenge is how we will manage and how the armed forces will manage this connectivity. And the connectivity is not only between man assets, not only between the operational forces, it's also between effectors and every sensors. So that's the main game changer. And we can typically, if we look what we're doing today, we're doing a video conference with many people from everywhere, and it was not possible a few years ago, a decade or more. Today, it's looked normal to everybody. This type of connection is not anymore a limitation for the armed forces. It is a new tool, and those armed forces have to use it. Sorry.
Okay, Monsieur Scourzic.
In terms of challenges, in particular when using these robotic systems, one challenge can be the GNSS denied environment, because many things rely onto GPS. So we'll have to find ways, for the systems to work in a GNSS denied environment, because if you don't know where your systems are, you have a problem. So there are ways around that, but it needs to be taken into account into the design of the system.
Thank you. And now I have, which might be the final question. When you have all this connectivity and you have a cloud and all these kinds of sensor data and information, can this result in an information overload on the tactical level? And how do you manage that?
Maybe I will take the first one. I think artificial intelligence and machine learning is offering some solution to solve, as you said, this kind of overload information. You have a second part of solution, which is to associate some calculation and storage systems the nearest you can from the sensor and the effector. It is called, as you all know, the edge part of the cloud.
Thank you.
Well, if I also totally agree with what Olivier said. I would just say that when you want to manage the information flow that you have, is a question of sort of time constraint. How much time do you have? And when you are building your situation awareness, when you are preparing to the combat, the time frame is not the same when you are defending yourself under attack. And maybe the space where you're defending yourself is a little different than the one you want to address when you want to build your overall situation awareness or understanding what's going on. So the time will be always a key element when you want to manage information. And that's for sure intelligence artificial. You will need some help. You will need some decision aid as the operator will be probably to make sure that the operator will take the right decision at the right time.
Okay, Monsieur Scourzic.
I have nothing to add to what has been said earlier. So
now, very last question: if these systems would not work, the connectivity is lowered dramatically because of some kind of countermeasure or electronic warfare. What will happen with the units? Will they still be able to make the right decisions swiftly in a tactical situation?
Well, if I start here, that's why we will always have the man in the loop. We need the man in the loop all the time. That's basically to be able to handle some lack of communication at one point, and that's what I was calling the man weapon teaming or the man on man teaming. As it's the same area, and it's a wide subject.
Yeah, Olivier, I totally agree with that. All those artificial intelligence systems must be executed under human supervision, for sure. There is also another characteristic, for example, for the cloud. If the cloud is embedded in a boat, it must offer some characteristic of autonomy. Even if the SATCOM or radio doesn't work anymore, you will have to benefit from your local cloud. That's to say, every part of the cloud must work autonomously from the other part, if you have to.
So now a final comment from Monsieur Scourzic.
Yeah, in fact, our systems are designed to be fully autonomous. So it means that if for any reason there is no communication when required, the system is programmed to go to wait or to go to a specific place or to start a specific task. So the systems are designed to be fully autonomous and to take action. I would say that they are programmed for if for any reason they're not able to communicate when they're supposed to communicate.
Okay, thank you very much, all three presenters. And I'd also like to thank the partners that have made this web conference possible at the Euronaval. So I hope that this is what has been an intense hour, and I hope that it's been rewarding to everyone. And I once again want to thank for the opportunity for me to be a part of this web conference. And thereby I end my mission here. Thank you very much, everyone attending this conference.
Thank you.
Thank you very much.
Thank you.
Bye-bye. Thank you.